first example comes from the top part of that worksheet, and it's just simply asking you to condense. So in the directions, underline the word condense. And what does condense mean? Make it smaller. So what I'm going to do is show you the process of going from the date, right? This is front seat, back seat of the date, all the way down to how it started. Can you tell me who's in charge of this date? Sinbad. So I'm going to write that trig word first. Okay. Now, Sinbad goes through the town shouting that their signs are the same, which means that it's addition. What two things get added? 97 degrees plus 43 degrees. So basically, we're working backwards to the start. Well, it said condense to one trig term. What's 97 and 43? 140 degrees. Okay, now let's watch from the bottom up and see how this works. If I was to find the sine of 140, I could split it into the sine of 97 plus 43, and then I could further put it into the date sine, cosine, plus cosine, sine. Personally, I would not use these angles because I don't know 97 or 43. But the point of the top portion was not for you to figure out the answer. It was to simply use the formula. Let me give you this. Okay, so now let's try the next one. This is number 3 on your sheet. So we obviously know that this is tangent. And what do you think it was before it was 140 and 60? 140 minus 60. Okay? And so what's 140 minus 60? 80. And that's all you have to do on the top part. Now, keep in mind that when you're finished, your answer should be one term, as condensed as possible. So if you have a problem on here that is in radian measure, then your final answer needs to be in radian measure as one angle. You can't leave it as pi over 3 plus pi over 4. Do the math. Add those two and come up with an answer. Do you remember what I said often during first semester about pi in the calculator? Don't what? Don't put the pi in the calculator. Don't put the pi in the calculator. Same thing for these. Don't put the pi in the calculator. Do the fractions, add the pi on at the end. Okay? So we okay on the top part. Top part is just basically how do I use the rules? How do I use the identities that I just learned? We're not answering the questions. We're just going back and forth. Okay. So now let's apply what we just learned. If I get this problem, tangent of negative 105, I have a couple choices. If I am allowed to give an answer that is not exact, then I would just simply go to my calculator and get it, but you can't. All your answers have to be exact. So what you're going to use is a sum difference formula, and you're going to use two angles that you already know that will either add or subtract to get you negative 105. Now, you can be creative. Cameron might use two numbers, and Kamal might use two different numbers, but in the end, their answer should be the same. Okay? So, somebody give me two numbers. This is where you can use your calculator to do a little simple math. I need two angles that we know already on the unit circle that will add or subtract to get me negative 105. $135 minus $240. Does that work? Okay? That's great. This is the fourth time I've taught this today, and that's the fourth different set of numbers I've used. And every time we come up with the exact same answer. As long as you do the math right, the answer is going to be the same. Okay? So, now we need to set up the problem. So if I'm subtracting here, what do I do in the numerator? Tangent of 135 minus tangent of 240. Over what? 1 plus their product. Tangent of 135 240. Okay, from this point forward, it's plug and play with what we know on the unit circle. And the only thing that I caution you about are the signs. We have to make sure that we get the signs right. So, what is the tangent of 135? Think about what quadrant it's in. It's -1. That's right. -1. Okay. Now I'm going to put the minus here. Let's think about 240. Where's 240 located? Third quadrant. Tangent in the third quadrant is, it's positive, is it not? So I'm okay with just that negative sign. Okay, now we got to go back and remember, how do we do tangents of other angles? Well, we say 240 has a reference angle of 60. And I gave you a little saying first semester about 30 degrees and 60 degrees. 30 degrees has all the threes. 60 degrees is just root 3. Okay? Okay? Now let's do the denominator. Be careful with the signs. 1 plus tangent of 135 we said was -1. And the tangent of 240 we said was root 3. So now we're going to clean it up. We can't leave it like that. So in the numerator, we're fine. -1 minus root 3. What do we have in the denominator? 1 minus root 3. And that is my final answer. Well, how do I know that's correct? Okay, here's what you do. You go back, you take your calculator, and you find the value of the tangent of -105, and you store it somewhere. Keep it. And then you come down here, and you put this -1 minus root 3 over 1 minus root 3 in the calculator, and you see if they're equal. If they're equal, you know you've done it right. If they're not, you go back, and the first thing to look for would be errors with signs. What do you think? Did we do it right? Yes? Okay, good. That's how you check your work. So you just found the exact value for the tangent of -105 by using angles that you already knew on the unit circle. Still not 100% clear? Let's try another one. This is like number 8. It is not number 8, but it's like number 8. And let's do two different values this time. Let's don't use the same numbers that Luke gave us earlier. Come up with some other angles that we can use to give us a 105. That's what I'm looking for. I like that. 60 and 45. You okay with that? So we're going to say the sine of 60 degrees plus 45 degrees. Would it be okay if I said 45 plus 60? Sure. Okay. Who's in charge of the date? Sinbad's in charge of the date. So let's set the date up. Okay, we always set the date up before we start doing the math. So this is going to be the sine of 60 degrees. Keep going. Cosine of 45. That's the front seat of the date. Plus cosine of 60 sine of, okay, so here's what you have to be careful of. In the front, you've got sine of 60, so in the back, you have to have sine of 45. Otherwise, you're doing the same thing in the front and the back, so they have to be different. Does it matter the order that I do these in? Can I switch? Could I have put sine of 45 first and then cosine of 60 second? Yes, I can. What's the rule that says I can do that? Commutative property of multiplication says I can do that. So now that we have it set up, we just do the math. What's the sine of 60? This is where your hand trick comes in. What's the sine of 60? Root 3 over 2. What's the cosine of 45? Root 2 over 2. Okay, that was front seat. All right, back seat. We go back to 60. What's the cosine of 60? 1 over 2. And what's the sine of 45? Root 2 over 2. Okay, now we just do the math. Root 3 times root 2. Root 6. Root 6 over, be careful, 4. You have to multiply denominators as well. Plus what? Root 2 over 4. Now for me, I'm perfectly fine. You can leave it like that. There's nothing wrong with that answer. There is a way that you could condense that, and we did it a lot last test when we were working with verifying. What's one thing I could do to clean it up and make it one term instead of two separate ones? Root 6 plus root 2 over 4. So either of those answers is good. Now, easy enough to check. We were doing, go back and find my problem, sine of 105. So put that in your calculator. Sine of 105, get an answer. And then come down here and check what you just got to make sure it's the same. Works okay? Excellent. That's how you know your answer's correct. All right, any questions now? Moving along. Okay, this is just an additional example. This is not on your paper, but I wanted to make sure that we did one with cosine as well. So I have cosine of 165. Probably the hardest part is coming up with two angles that you know that will equal 165. 45 and 120? Would that work? And I need to do what? Add or subtract? Add. So I'm going to set it up like this. Cosine of 45 degrees plus 120. Okay, who's in charge of the date? Cosette is in charge of the date. So, set it up for me. Cosine of 45 degrees, not plus, times cosine of 120 minus, why minus? She goes to the town shouting that their signs are not the same. Sine of 45, sine of 120. Okay, now we got the date set up. We just do the math. What's the cosine of 45? Root 2 over 2. All right, so let's do 120. What quadrant can we find 120? Second, that means cosine is negative. What's the reference angle? 60 degrees. Cosine. Isn't it negative 1/2? Okay. Minus sine of 45. Root 2 over 2. And the sine of 120. Remember, we were using 60 as a reference angle, so it's root 3 over 2, and it's positive because sine is positive in the second quadrant. Okay, so now we just do the math. This is not subtraction, this is multiplication. So what do I get on the left? Negative root 2 over 4 minus root 6 over 4. Or I can combine it. Now, true or false? Negative root 2 minus root 6 equals negative root 8. False. Seriously false. You cannot do that. Okay? You can check in your calculator too if you put in negative root 2 minus root 6 and get an answer, and then put in negative root 8 and get an answer. They're different. You can't add them like that. All right, any questions on this one? It's not too bad. Better? Okay, so here's where it gets a little tricky. And this is a throwback to a test that you took first semester with the basic trig functions where you had to draw triangles. So what I want you to do first, this is problem 9. I just changed the angle notation to x. But this is problem number 9. So on your paper, you're not going to have enough room to do it on the worksheet. On your paper, write down the stem of the problem, and then we'll work it out together, and I'll show you the process for working it out. You had a test first semester that had you sketching triangles given trig ratios and then it would tell you what quadrant to put it in, and then you had to find the other 5 trig ratios based on what they gave you. You're going to need some room on this, by the way. Yeah. The only 2 things that will be on this test are sum difference and double and half angle. All right, does anybody have any idea how we should approach this problem? I kind of alluded to it. Draw triangles. Exactly. Only we don't draw one triangle, we have to draw 2 triangles because we actually have 2 different angles. We have angle X and we have angle beta. Okay? So this is the method for doing this problem, and it's going to look really familiar to what you did on one of your last tests that you took first semester. So let's draw an X and then an X and Y axis, and we're actually going to create the triangle that holds angle X. So the clue that we're given says that it can be found in the quadrant that holds pi over 2 to pi. So what quadrant would that be in? Second quadrant. So we're going to build our triangle in the second quadrant. And when we build it, we're going to label it. There's our right angle. And this angle coming from the origin, as always with a unit circle, that's the angle in question. So that angle is actually x. That's what we're looking at. So it gave us the cosecant as 13 over 5. Well, I don't really think in terms of cosecant. I think in terms of sine. Sine is the ratio of y over r. So cosecant must be the ratio of r over y. So r would be 13, and y would be 5. And now I need to find x. Some of you may know this. A Pythagorean identity, we could do that, x squared plus y squared equals r squared, but some of you may already know what this is. This is a really common triple. It's 12. It's not positive 12, though. It's negative 12. Why is it negative 12? I'm in the second quadrant. So that's one place to watch out for errors. Make sure that your signs are the same as they should be in that quadrant. Now, if you go back and add, just to verify, 12 squared is 144, plus 25 gives you 169. Square root of 169 is 13. So if I need to do that outside, then I'm just going to use Pythagorean identity. Okay, I'm done building angle X. So now I got to come over here and build angle B. All right. The clue, it says that beta is located between 3 pi over 2 and 2 pi. Fourth quadrant. So I build it in the fourth quadrant. And that is angle beta coming out of the origin. Okay, so it tells me that the tangent is negative 3/4. Well, tangent is the ratio of y over x. So which of those gets the negative? That's right, the y. So this would be negative 3. This would be 4. And then the radius would be 5. Always positive. The radius is always positive. All right, so now I'm finished setting up the problem. I need to set up the date. Okay? So for the date that we're going to find, who's in charge? Sinbad. So let's write the date out. We have the sine of x, cosine of beta, minus cosine of x, sine of beta. Okay, so what we have to do now is go to each of those triangles and pull those ratios. So this says the sine of x, and that's why I labeled it very clearly. What is the sine for this triangle. So we put that down, 5/13. And then it wants the cosine of beta. So we got to go to this triangle. What's the cosine of triangle B? 4/5. Minus. I always put parentheses so I don't get messed up with negatives and drop something that I shouldn't. What is the cosine for angle X? -12/13. And what's the sine of B? -3/5. Okay. What do I do with these two fractions here? Multiply. So this becomes 20/65. I have three negative signs. If you have an odd number of negatives, then still negative. 36/65, which makes your final answer -16/65. Okay, so let's just kind of repeat the process. On problems like that from that section, the first thing you do is build each triangle separately according to the clue that they give you for where the angle is located. You'll always get a clue. Okay? Once you've built each triangle, you set up the date. After you set up the date, you just plug it in. Okay? Now, there actually is a way for you to check these answers. If you want to learn how to check these answers, you let me know, and I'll show you guys during advisement, or you can come in for a help session. Okay? But if you're curious as to how you can check these answers, because we don't actually have an angle, do we? We'd have to find it using an inverse function, and we can do that, and it might take a minute, but if it would make you feel more comfortable to have a way to check your work, then I'm happy to show you that. Okay? All right. Last one for today, and then you're going to have some practice time. We're going to verify using a sum difference formula, and these are actually very easy. What are the rules for verifying? You got to make the left side equal the right side, and then there's really just one more rule. You can't work on both sides. Pick a side. So does it make sense to work on the right-hand side? No. So what we're going to do is work on the left. And when I say work on the left, what's a math word that I could use that would explain what I have to do? Expand. I have to expand the date, basically, if we're using the Sinbad and Cosette love story. So let's set up this date on the left. Who's in charge? Sinbad. So he's going to sit in the front. Oops. He's going to sit in the front with Cosette. So there we go. There's the front seat. He goes through the town shouting that their signs are the same. So this should be minus. How do I set up the back seat? Cosine of pi, sine of x. So we're only working on the left-hand side here, just like we were before. Okay. We actually know the sine of pi. What is it? It's 0. So we show 0 times the cosine of x. Remember, the point of verifying is to show that it's true, not assume that it's true. So let's go to this one. What's the cosine of pi? -1 times the sine of x. Okay, now what does 0 times anything equal? And then I have two negatives, which makes it, and we're finished. Sine of x equals sine of x. Now, there are some verify problems in here where you actually have a date plus another date. Just set them both up. And as long as you set them both up correctly, something is going to cancel, and you'll get left side equal to right side. But it's as simple as just expanding or setting up the date, as it were. Okay? So, you have about 8 minutes until the bell rings for advisement. Work on these some. And then when you come tomorrow, have them finished so that we can start the lesson with, okay, I tried to do this one and I don't know how to do it. Can you work it with me? And then I'm going to give you some more practice tomorrow. And then after tomorrow, I'll feel comfortable with you guys working on WebAssign. Okay? And I have a key right there if you just can't wait.